children, today we are moving to the next topic, that is critical angle and total internal reflection. As you all know, when a light ray travels from rarer to denser medium, it bends towards the normal. Hence, the angle of incidence will be greater than angle of refraction. Now, if a ray travels from denser to rarer medium, it's bent away from the normal, in which the angle of incidence is less and the angle of refraction will be more. We can consider such a case. Consider a ray of light travels from a denser medium to a rarer medium, say glass to air. Here, this is the normal to the point of incidence, and when it reaches to the surface separating the two media, a small portion of light will be reflected and most of the light refracted in such a way that it bends away from the normal. Now, if I is the angle of incidence, then R will be the angle of refraction, and here I will be always less than R. Because I is the angle of incidence, when the ray bends away from the normal, the refracting angle will be greater than angle of incidence. So, when a ray of light travels from denser to rarer medium, it bends away from the normal. Hence, the angle of incidence will be less than that of angle of refraction. And this part of light which is reflected will not be considered here because we are discussing only about refraction. Now, if we increase the angle of incidence, what will happen? The angle of refraction also increases. So, for a greater angle of incidence, the angle of refraction will be greater. In all such cases, there is a part of light reflected. Now, if we do so, that means if we increases the angle of incidence, at last we will reach to a position where the angle of refraction will be 90 degree. So, for a particular angle of incidence, the angle of refraction will be 90 degree. When the angle of refraction is 90 degree, the ray passes through the surface separating the two medium. So, when a ray of light travels from denser to rarer medium, it refracts and bends away from the normal in such a way that angle of refraction is always greater than angle of incidence. And if we increase the angle of incidence, at a particular angle of incidence, the angle of refraction will be 90 degree and the ray of light passes through the refracting surface or the surface separating two media. Here also a part of light will be reflected by obeying laws of reflection. What is laws of reflection? Angle of incidence is equal to angle of reflection. So, here also a part of light is reflected and most of the part refracted through the refracting surface. And this angle of incidence is called critical angle. This angle of incidence is called critical angle. So, critical angle is the name of the angle of incidence when the angle of refraction is 90 degree. Or we can define critical angle as it is the angle of incidence in the denser medium where the angle of refraction in the rarer medium is 90 degree. So, critical angle is the other name of angle of incidence when the refracting angle is 90 degree, and when angle of incidence is equal to critical angle, the ray of light passes through the surface separating the two media. Let's go in detail about this critical angle. When the angle of incidence is equal to critical angle, the angle of refraction will be 90 degrees. So here in this case, the angle of incidence is equal to critical angle and the angle of refraction is equal to 90 degree. So according to law of refraction, we know that sin I by sin R, or sin of the angle of incidence to the sine of the angle of refraction, is equal to refractive index of the second medium with respect to the first medium. Here the angle of incidence is critical angle, so we can write sin C. And what is the angle of refraction? Corresponding angle of refraction is 90 degrees, so we can write sin 90 is the refractive index of the second medium. Here the second medium is the rarer medium and the first medium is the denser medium, because we are considering the case of a ray of light traveling from denser to rarer medium. So here we can write the refractive index of the second medium, that is rarer medium with respect to denser medium. If it is in the case of glass and air, it is the refractive index of air with respect to glass. Okay, so this is sin C by sin 90. What is the value of sin 90? Sin 90 is 1. So we can write refractive index of the rarer medium with respect to the denser medium is sin C. We always think about the refractive index of denser medium with respect to rarer medium. As we all know, refractive index of the rarer medium with respect to the denser medium is the reciprocal of the refractive index of the denser medium with respect to rarer medium due to the principle of reversibility of light. So here we can apply the principle of reversibility of light. So refractive index of the denser medium with respect to rarer medium will be 1 by refractive index of rarer medium with respect to the denser medium, and it is equal to 1 by sin C. So this is the relation connecting the refractive index of the denser medium and the critical angle. The refractive index of the denser medium is 1 by sin C. Or when in the case of light traveling from glass to air, the refractive index of glass is 1 by sin C. In the case of light ray travels from water to air, the refractive index of water is 1 by sin C, or the absolute refractive index of the denser medium is always 1 by sine of the critical angle. For example, as we all know, the refractive index of normal glass with respect to air, or the absolute refractive index of glass, is 3 by 2. And according to the relation between critical angle and refractive index, the refractive index of the denser medium is 1 by sin C. So we can write refractive index of glass, or 3 by 2, is equal to 1 by sin C. That is, sin C is equal to 1 by refractive index of glass with respect to air, that is 2 by 3. So the angle C is sine inverse 2 by 3. When we take the sine inverse, we will get C is equal to 42 degree. That means critical angle of glass is 42 degree. So from the refractive index, we can predict the critical angle of a denser medium. The critical angle of some of the materials are here. For example, water has a critical angle of 49 degree and normal glass has a critical angle of 42 degree. Flint glass is having a critical angle of 32 degree and diamond is having a critical angle of 24 degree. Now, let's look the factors affecting critical angle. The critical angle, being an angle of incidence, it depends on two factors. The first one is the color or wavelength of light and the second is the temperature of the medium. The refraction or the deviation of light is more for shorter wavelength. Therefore, the critical angle for a pair of media is least for shorter wavelength and most for longer wavelength. That means the violet light has smaller critical angle and a red light has larger critical angle. Hence, critical angle increases with increase in wavelength of light. On increasing the temperature of the medium, the refractive index decreases so that the critical angle for that pair of media increases. Thus, critical angle increases with increase in temperature. Now we can look what will happen if the angle of incidence is more than critical angle. So, let's look in detail. If the angle of incidence is equal to critical angle, this is denser medium and this is rarer medium. If the angle of incidence is equal to critical angle, the light ray travels through the surface separating the two medias and the angle of refraction will be 90 degree. So, if the angle of incidence further increases, then the light ray will not refract. Instead of that, the light ray reflects by obeying the laws of reflection. What is laws of reflection? Angle of incidence is equal to angle of reflection. For example, if the critical angle is 45 degree, then when the angle of incidence is 45 degree, then the angle of refraction will be 90 degree. If we increase the angle of incidence, that means if the light ray incidence with an angle of incidence greater than 45, say 50 degree, then the light ray reflects. By obeying laws of reflection, that means the angle of reflection also will be 50 degree. Since the angle of incidence is 50 degree. If it is 55 degree, then the angle of reflection will be 55 degree. That means till the critical angle, the ray refracts when it travels from denser to rarer medium, and if the angle of incidence is greater than critical angle, the ray reflects. In such cases, the total ray reflects back. In all the other cases, we have seen some part of ray reflects and the refracted ray will not contain 100% of the incident ray. But here, the 100% of the incident ray reflect and there will not be any loss of energy in any other means. So, this reflection is called total internal reflection. So this is called total internal reflection. Here 100% of the ray reflected back to the denser medium. Hence, the condition for reaching the critical angle is the light ray should travels from denser to rarer medium and the angle of refraction must be 90 degree so that the angle of incidence is called critical angle. So, only one condition to reach the critical angle, that is the light ray should travels from denser to rarer medium, or the critical angle happens only when light ray travels from denser to rarer medium. Now let's go in detail about total internal reflection. So what are the conditions for total internal reflection? First of all, the light ray should travel from denser to rarer medium. And the second is the angle of incidence should be greater than critical angle. So to attain the condition of total internal reflection, the light ray should travel from denser to rarer medium and the angle of incidence should be greater than critical angle. Now what is total internal reflection? Total internal reflection is a phenomena which happens when light ray travels from denser to rarer medium with an angle of incidence greater than critical angle, so that the total light reflected back to the same medium. You can see the example for total internal reflection if you look around. For example, the critical angle of water is 48 degrees. The ray of light entering water from below surface. The critical angle of water is 48 degrees. The rays of light entering water from below suffer refraction. If this rays strikes on water air surface at an angle which is greater than 48 degrees, they get total internally reflected. These rays on emerging out of water appears to come from the upper surface, and hence the upper surface of the water is seen as silvery. So when total internal reflection happens, we feel that the surface which suffer total internal reflection as illuminated. This is the reason why we see the sparkling in diamonds. The diamond has a critical angle of 24 degrees. Diamonds are cut at very sharp angles, making a number of refracting surfaces. When a ray of light enters a diamond, it suffers a series of total internal reflection due to large number of refracting surfaces and because of very small value of critical angle. Thus, the ray of light in a way gets trapped within the diamond for some time. It is this trapped light energy which makes it sparkle. The cut glass articles also sparkle because they have a number of refracting surfaces from which total internal reflection can take place. Also, bubbles of air rising up in a fish tank appear silvery if the rays of light strike them at an angle which is greater than 48 degrees, that is the critical angle of water. On a hot sunny day, a driver may see a pool of water in front of him at some distance away from him. This phenomena is called mirage, and which is also the result of total internal reflection. Hope you all understood critical angle, total internal reflection and all the examples involving total internal reflection. Thank you and have a nice day.